So now a natural phenomenon that's associated with physical mechanisms. Okay? It's called the spring bloom in the North Atlantic. So every year, spring month, you get the development of phytoplankton blooms in vast areas in the North Atlantic. Okay, so vast areas shown here in this satellite image. You get almost the entire North Atlantic region creates this bloom. Okay, so how it is formed is it's formed in the transition of deeper convection, where the mixed layer is very deep, to the time of when solar heating kicks in and creates temperature controlled stratification in the ocean. So from one situation where your plankton spores are the parts of the plankton that actually start the plankton blooms, where they are mixed over 1,000 meters, so only spend a little time within the euphotic zone, to a time where you have a constrained surface mix layer, and you have mechanisms that you have enough nutrients within that surface mix. And the nutrients come from the winter convection itself. That's why there are high nutrient concentrations to start with. And this is a little sketch here of showing a little sketch of how it works from winter to spring. So you have high surface nutrients because in winter you have little sunlight available in the region. Okay, plus you have a very, very deep mixing in this area. And then you get the spring bloom. You get the spring diatom bloom in the region because you have enough nutrients and constrained to the surface mix layer. And then after a while, the nutrients are used up, and you get a decrease in the diatom bloom goes back to zero at the end of spring, while you have in a delay the zooplankton bloom still. You can see that afterwards during summertime. Okay, in autumn you get a similar type of bloom, but this is when the storms kick in, and the storms can create mixing and mix up nutrients to the surface. Okay, so this is a widespread phenomenon in the North Atlantic. Okay.